All right, we are in AP Stat, and we are in Unit 2, and we are still in Scatterplots. These are some practice problems in Chapter 7 on Scatterplots. We've been kind of going over the idea of explanatory versus response variables. Do you notice correlations or not with them? Do you notice patterns in them? Are they tight patterns? Things like that. So again, if I'm moving too fast for you, that's fine. Just pause the videos. That'll help out a lot. Write down the problems so you can see what's happening. So a study examined brain size, okay, and IQ. The scatter plot shows the performance IQ scores versus the brain size, right? The comment on the association between brain size and IQ as seen in the scatter plot are next to it. So the point is, there we go. We got the size of the brain, and we have their performance IQ. All right, so it says the scatter plot of IQ scores versus brain size is pretty scattered. There isn't a ton of a pattern. I mean, some would try to argue that it looks like they're going up, but even if it did, it's not very strong, right? So it says there appears to be little or no association necessarily between the IQ scores and brain sizes displayed. You could try to argue there might be very little. It may be a weak positive association, but then even still, these are up here and these are down here, so that's why they're going with that. There's probably no real association with it, right? Taking a look at this one, it says the fastest horse in the Kentucky Derby history was Secretariat in 1973. Okay, the scatter plot shows speeds of the winning horses each year. And what do you see? All right, and what it looks like is, at first you could argue, well, it's straight, but I don't know. It kind of looks more like maybe it's curving a little bit, right? Just a little bit, like kind of like that's kind of peaked what the horses could be at. It says, in most sport events, performance have improved and continue to improve. So surely we anticipate a positive direction because it's just what happens. But what of this form, and has the performance increased at the same rate throughout the 130 years? So it looks like the winning speeds in the Kentucky Derby have, for the most part, increased, and it seems to be a reasonably strong pattern. Like, you could argue that they are increasing. The association between years and speed is moderately strong, right? It looks like they're going up as we go for the most part. Greater rate of increase in the winnings before 1950, right? It looks like a pretty sharp increase then, as opposed to after that it just kind of fizzled off. And a smaller rate of increase after that, suggesting that the winning speeds have leveled off over time. So we were arguing had happened. But yeah, for the most part, all they want you to do is just kind of describe what you're looking at. Owners of a new coffee shop track sales for the first 20 days and displayed data in a scatter plots. The first 20 days of sales, and then how much money that they're basically making in those days. So like day 1, 2, 3, like so on, the whole way up the line. And it looks like it's for the most part positive, like the sales and things are going up. I mean, it's kind of all over the place. But it says make a histogram of the daily sales since the shop has been in business. State one fact that is obvious from the scatter plot but not from the histogram. And it looks like there's a positive association, like as it goes, it's going up, right? It's a state one fact that is obvious from the histogram. So, taking a look, a histogram of the daily sales, right? Basically, what we have is the daily sales, right? One, and then that's the frequency. So, there's 2 sales, right? There's 1, 2, 3, 4 sales. There's 1, 2, 3, 4, 5, 6, 7, 8. Right over here, 4. There's 4. Here, there's 2. So it looks basically pretty normal, right? Is what the histogram's looking like. Looks like right here, sales. $300 sales is their most frequent occurrence after those first 20 days. It says the scatter plot shows that in general the sales have been increasing over time. It looks like they have been. The histogram doesn't seem to show that. The histogram shows that the mean of the daily sales is, though, in between $300 to $400 a day, and that happens on about 8 different occasions. So the scatter plot does not show that. So the idea behind this problem is to get you to see, like, you're noticing that a good average for this, it seems pretty normal with what they have so far. And with it being pretty normal, it looks like they could bank on about $300 to $400 a day, somewhere in between there. But the scatter plot shows, though, as time has went on, it looks like the price has gone up, right? As much money as they're making continues to rise. So looking at the two from each standpoint, well, how do you know which one to base it off of? Well, hopefully we'll get to that stuff later down the line. A researcher studies children in elementary school and finds a positive and strong linear association between the height and reading scores. Does this mean that taller children are generally better readers? And what might the strong correlation be? It says, actually, according to this does mean that taller children in elementary school are better readers, according to their data. However, this does not mean that the height causes good reading ability, just because this is that idea that we were getting at with causation. All right, just because a scatter plot is positive doesn't mean it causes it. I'm noticing that taller kids are better readers, but that doesn't mean that because they are tall, they are better readers. There is no cause to it. That's what we are implying with that idea of causation. Just because there is a correlation, that doesn't mean that there is a causation. Doesn't mean that one causes the other to happen. That's not what this means at all. It just means that I'm noticing a pattern. I'm noticing an association between the two. That's all that it means. What might explain the strong one? Well, they're just older. And normally if you're older, right, older children are generally taller. It just happens. So, and if you're older, you can probably read better as well, right? So that means the lurking variable here, it's probably age. What people aren't accounting for. That's what a lurking variable is. It's like, oh yeah, that's probably why that is the case. Taking a look at this one. A survey of the world's nations in 2004 shows a strong positive correlation between percentage of the country using cell phones and life expectancy in years of birth. Does this mean that cell phones are good for your health? It says that shows a strong positive correlation between percentage of the country using cell phones. So the more cell phones you use and life expectancy is going up. Simply means that in countries where cell phone use is high, the life expectancy tends to be high. So does that mean that cell phones are good for your health? No. Why? Because that's too general. I don't know where this took place. Survey of the world's nations. Okay. But how do I know that's always the case? I don't know where they are. So that means that countries where cell phones are used, the life expectancy also tends to be higher. And what might explain that correlation? Well, economics, right? Think about it. In the U.S., that very well could be the case. But what about older people in, countries in desolate areas? What are they supposed to do, right? So think about it like that. What do they do? Do you think that there's, just because they have a cell phone means that they're going to be living longer, right? So the amount of money you have, and they may be able to afford it. So that could be a lurking variable in here. The correlation between age and income as measured on 100 people is this. So there's your correlation, 0.75. Explain whether or not each of these possible conclusions is justified. When age increases, income increases as well. 75% of the time, maybe. 0.7, or I guess not percent of the time, but there is an association. So as we look at this, it says that, is that the case? No, we don't know this from the correlation alone. The relationship between age and income may be nonlinear, or the relationship may contain outliers. So maybe, right? It's not enough to tell me that yet. As age increases, income will, right? The form of relationship between age and income is straight. No, I mean, we don't know that for certain either. We can't tell the form of the relationship. We need to look at the scatter plot to see, does it look like it's going straight with all the points? There are no outliers in this. Again, no, the correlation between age and income doesn't tell us anything about that. So this correlation isn't really helping us. I need to see that scatter plot. Whether we measure age in years or months, the correlation will still be that. And that is correct, because correlation is like a z-score, and it's a standard value, so it doesn't matter whether that happens to be a different time or unit of time, it would still be unaffected. It should still be the same, which is something key to keep in mind. Medical researchers followed 1,435 middle-aged men for a period of 5 years, measuring the amount of baldness, 1 being 1, all the way up to 5 being, oh yeah, it's extreme, and presence of heart disease, yes or no. They found a correlation of 0.089 between the two variables. All right. Comment on their conclusion that this shows that baldness is not a possible cause of heart disease. Well, even though the variables baldness and heart disease were assigned numerically, which they were, they're still categorical. And correlation is only an appropriate measure of strength of linear association between quantities. So, point is, these aren't quantities. I can't use a scatter plot to look at it. It doesn't matter if they switch them into numbers. They're still categories that we're looking at, not quantities per se. So a scatter plot isn't going to work at all for this. Is basically what this is getting at. We come back here, I'll take a look at some more examples.